Have you ever really stopped to think about that complex network humming away inside your walls and on your roof? I mean, it's this invisible giant we rely on every single day for our comfort, right? Keeping us cool when it's hot and cozy when it's not. Well, today, we're going to pull back the curtain on that giant.
Okay, so let's just dive right in. We're starting with the sheer scale of these systems, because, spoiler alert, that little thermostat on your wall, it controls one of the biggest power players in any building you walk into.
I want you to think about it for a second. Picture a big office building, or maybe a shopping mall. You've got all the lights, the computers, everything plugged in. What do you think is quietly consuming the most energy out of all of it? Well, here's the answer. Take a look at this. Yeah, lighting and computers, they're definitely up there. But heating alone accounts for a whopping 46% of energy use. And when you add cooling and ventilation to that, HVAC systems can be responsible for well over half of a building's entire energy bill. That's a staggering amount of power.
But here's where it gets even more interesting. It's not just about the energy these things use. It's about what's inside them. The chemicals, the refrigerants, are often these things called F gases. Now, they only make up about 2% of total greenhouse gas emissions, which sounds small, right? But here's the catch. They are incredibly potent. They punch way, way above their weight when it comes to their impact on global warming.
So, okay, we've established they're huge energy hogs with a potent secret. But what exactly are we even talking about when we say HVAC? Let's get down to the basics.
You've heard the acronym a million times, but it just stands for heating, ventilation, and air conditioning. And the key word there is integrated. It's not just one thing. It's a whole system designed to manage the entire indoor environment. Everything from how hot or cold it is to the humidity and even the quality of the air you're breathing right now.
So how does the air conditioning part actually make things cold? Well, at its heart is something called the refrigeration cycle. And honestly, the best way to think about it is like a heat sponge. You've got this chemical, a refrigerant, that flows through coils and literally absorbs heat from your indoor air just like a sponge soaking up water. Then, the system squeezes that heat-soaked refrigerant, forcing it to release all that absorbed heat outside. It's just this constant cycle of soaking up heat indoors and wringing it out outdoors.
Now, it's super important to realize that the HVAC system cooling your house is a completely different animal from the beast that's managing a massive office building. Let's put them side by side. This chart just lays it all out perfectly. I mean, look at the size difference. Your home system is probably between 1.5 and 5 tons. A big commercial system, it can be over 30 tons. Your house probably has what's called a split unit, one part inside, one part outside. But a commercial building, it's likely got this massive all-in-one packaged unit sitting up on the roof. You'll hear people call it an RTU. And the complexity, it's just a whole other level, with extra gear like cooling towers and these huge sprawling networks of ductwork.
Okay, so given their massive energy footprint, the really big question is, how do we make these things better? And that, of course, brings us to the next generation of HVAC tech.
One of the most clever solutions that's really catching on is the hybrid system. It's brilliant, really. It just takes two different technologies and makes them work together for maximum efficiency.
So here's how it works. On a kind of chilly, mild day, a super efficient electric heat pump does all the work. But let's say a real cold snap hits. The system is smart. It knows the heat pump is going to struggle, so it automatically switches over to the more powerful gas furnace. The whole point is, the system is always using the most cost-effective and efficient fuel source for whatever the weather is doing outside. And the result of all that intelligence? Well, according to one case study, homeowners who made the switch saw their energy bills drop by as much as 30% over a year. That is a huge savings.
But remember, efficiency is only half the battle. Remember those potent F gases we talked about? Well, the industry is going through a massive shift in the actual chemistry it uses. On the left, you've got R22. That's an older refrigerant with a global warming potential of 1,810. That means it's over 1,800 times more potent than carbon dioxide. On the right, you've got a new one, R290, with a global warming potential of just 3.
Let me put that difference another way for you. When you do all the math, the new R290 refrigerant is over 1,300 times more environmentally friendly. That is just an unbelievable leap forward. It's a total game changer.
And look, this isn't just theory. These numbers come from real, hands-on research. What you're looking at are the actual lab setups where scientists ran 2 identical air conditioners, one with the old R22 and one with the new R290, to measure the difference and prove it.
This quote from the research paper really just says it all, doesn't it? The science is clear. Changing the chemistry leads to a monumental environmental benefit. It's just that simple.
So what does this all mean for the future? Well, it means we're looking at a whole new era of climate control, one that is both intelligent and, truly sustainable.
So let's just recap the big takeaways. First, HVAC is this hidden giant, a massive energy consumer. Second, the systems themselves are getting so much smarter, automatically picking the best fuel for the job. Third, the shift to cleaner chemistry, to things like R290, is drastically cutting the environmental harm. And what that all adds up to is this: our future comfort doesn't have to cost the planet.
And that really leads us to a final, pretty crucial question. In a world that's getting warmer, we rely on this technology more and more. So the real challenge and the opportunity is how we continue to innovate, to make the very systems that cool us down a key part of the solution instead of part of the problem.